Working principle of a three-phase induction motor. Any electrical motor is defined as an electromechanical device which converts the energy in electrical domain to the mechanical domain. The operation of a motor can be explained as follows. If we assumed that it is a stator of an three-phase induction motor. And those are the conductors of rotor conductors. And this is the air gap between the stator and the rotor. When a three-phase winding is energized from a three-phase supply, that means when stator winding is energized from a three-phase supply, a rotating magnetic field is created here, which rotates round the stator at synchronous speed. That speed ns is equal to 120 f by p, where f is the frequency and p is the pole of number or number of pole. The rotating field passes through the air gap and cuts the rotor conductors, which yet is stationary. Due to a relative motion between the rotor conductors and the rotating flux, EMF are induced in the rotor conductors. Since the rotor circuit is short-circuited, current starts flowing through the rotor conductors. The current carrying rotor conductors are placed in the magnetic field produced by the stator. Consequently, mechanical force acts on the rotor conductors. Force of rotor conductors are in this side. The sum of the mechanical force on the rotor conductors produced a torque which tends to move the rotor in a same direction as the stator rotates. The fact that the rotor is urged to follow the stator field, rotor moves in the same direction as stator field rotation. That is explained by Lenge's law. According to this law, the direction of the rotor current will be such that way that tends to oppose the cause of its production. Now the cause of its production is rotor current is the relative speed between the rotating field and the stationary rotor conductors. Hence, reduce this relative speed, the stator starts running in the same direction as the stator field tries to catch it.